Have you ever wondered why men's buttons are traditionally on the right side of a garment and women's on the left? Legend has it that this enabled a man to unbutton his coat with his left hand while drawing a sword with his right. Wealthy women, meanwhile, had their buttons sewn on the left side to make it easier for their right-handed maids to dress them. One way to make plastic buttons uses a multi-layer sheet of synthetic resin, hence the industry term sheet buttons. Workers start by mixing liquid polyester resin with a catalyst to gel it. They pour the material into a revolving drum which disperses it evenly. They spray a solution containing an ultraviolet pigment on this first layer only. You'll see why later on. For this particular model, they make grooves in the resin while it's still malleable. This will create a design. After about 5 minutes, the resin gels, and they can mix and add a second layer in a different color. Besides building up the thickness of the sheet, the resin flows into the first layer's grooves, creating a design of contrasting lines. Once this second layer gels, they mix and pour in a third color. The drum spins for another 10 to 15 minutes until all the layers cure. A resin sheet can be comprised of up to 4 different color layers. Workers can now remove the sheet. It's hardened enough to be cut into buttons, but it's still flexible enough not to crack when cut. Now they feed each sheet into a press that's outfitted with a die for that particular button model. The press punches out circles in the diameter of the button. These circles are called blanks. You can see the different color layers. The blanks move on to the machining center where they'll be transformed into buttons. Automated equipment loads them onto carousels, the back of the blank facing outward. How does the loader know which side is which? Well, remember that ultraviolet solution the worker sprayed onto just the first layer of resin? A UV detector scans each blank to make sure that first layer is facing upward. If it isn't, the machine rejects the blank, then flips and reloads it. The carousels first run the back of the blank against a series of cutting heads. The heads are changed according to the model being produced. For this one, the heads gradually carve a curved back. The equipment then transfers the blank onto a second carousel, exposing the front side this time. Again, a series of cutting heads gradually carve the front of the button. The shape of this model exposes the different color layers underneath, creating a veined effect. The last cutting head drills the holes. Here you can see the full progression from blank to button. Now they polish the buttons for several hours in drums containing abrasive ceramic stones and pumice. Then workers flush the drums with water. The heavy polishing stones sink to the bottom. The lightweight buttons float to the surface and spill out. The buttons then go into drums that contain silicone wax and thousands of tiny wooden pegs. While the drums spin, the pegs act as a carrier, distributing an even coat of wax. As the buttons exit the drums, the pegs are screened out. From here, plain buttons are often custom dyed to match fabric swatches provided by clothing manufacturers. Well, you've seen how they manufacture some types of buttons. just a few of the many styles on the market. There are several different ways to produce these handy little fasteners, so forgive us if we buttonhole you to stay tuned and watch some more. Archaeologists have unearthed bone buttons dating back to prehistoric times. The ancient Greeks and Romans used buttons to both fasten and decorate their clothing. Europeans wore buttons strictly for adornment until about the 1200s. That's when fitted garments became the trend, fastened by a long row of buttons down the front. The rich wore buttons made of silver or gold, sometimes set with precious gemstones. Ordinary people wore buttons made of mere bronze or wood. This is another way to make plastic buttons using polyester resin. Only instead of turning it into sheets, they pour the resin into long metal tubes. Here they're mixing two different colors to create a design in the plastic. The tubes go into an oven where they bake at 100 degrees Celsius for about an hour until the liquid resin hardens. Once the tubes cool off, workers remove the contents. These long resin rods will become what the industry calls rod buttons. The rods go into a machine called the slicer. Its sharp carbide blade chops the long rods into button-sized blanks. Here's what that looks like in slow motion. It's no use showing you this at regular speed. It would be but a blur. This machine cuts up to 700 blanks per minute. Blanks cut from resin rods run through the same machining center as those cut from resin sheets. In the last segment, we showed you the machining steps in slow motion. Here's what they look like at actual speed. Any type of button can be engraved with a company name or logo. They do this using a computer-programmed laser machine. The laser beam burns the lettering into the plastic. Workers visually inspect the finished buttons to make sure that none have defects. Another way to make plastic buttons is by what's called thermoset compression, a technique that combines both heat and pressure to mold the button's shape. As we see here in slow motion, the raw material isn't liquid resin, but rather melamine powder. A pill-making machine, the kind pharmaceutical companies use, compresses the powder into pill-shaped blanks. Here's what that making action looks like at actual speed. To transform these pills into buttons, workers load them onto a press. The press uses high pressure to force each pill into a button mold for a period of 40 seconds to a minute, depending on the size of the button. At the same time, it heats the mold to 163 degrees Celsius. This bakes the melamine into hard plastic. They cool the molded buttons in a basin of cold water. Some specialty buttons go on to be gold-plated, but not before soaking in a chemical bath to clean their surface so that the plating will bond well. As a rule, only materials that conduct electricity can be metal-plated. Plastic, of course, is non-conductive. However, this company has managed to devise a way to gold-plate plastic buttons. Exactly how is a closely guarded secret it's not willing to divulge. After plating the buttons in copper, a 12-hour process, They plate them in nickel, which takes just a couple of minutes. And finally, in 24-karat gold, which takes just a few seconds. A mere 28 grams of gold is enough to plate 82 kilograms of buttons. Thermoset compression buttons are a lower-end product used primarily for uniforms. Sheet buttons and rod buttons are higher quality, the standard choice for fashion clothing.